Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's the problem for today for exam P on probability. Mr. Warwick Beige is gambling at the newly opened You Was Robbed casino in Nevada. In the game he is playing, first he has to choose one of two coins, coin A or coin B. Both coins are unfair. Coin A has the property of heads of 0.60 and coin B has the property of heads of 0.40. Mr. Beige pays $20 to enter the game. He chooses a coin randomly, but the chances of picking the coins are not equal. He has 40% chance of picking coin A and 60% chance of picking coin B. Then he tosses the coin chosen. If the result is heads, he is paid $250. If the result is tails, he pays $200. For an additional payment of X dollars, Mr. Beige can test a coin chosen. He can toss it once and based on the result, either walk away and get $20 paid initially back. He will do this if the first toss results in tails, or toss the same coin again. He will do this if the first toss results is heads, assuming that Mr. Beige values all gambles based on the expected value of the payoff, so he is what is called risk neutral. Calculate the value of X such that Mr. Beige is indifferent between testing a coin and not testing it. Here's the solution. We begin by labeling the events. A, coin A is picked. B, coin B is picked. H1, first toss results in heads. T1, first toss results in tails. H2, second toss results in heads. T2, second toss results in tails. We know, we actually are given that probability of A is 0.40, probability of B is 0.60, probability of H1 given A is 0.60, and probability of H1 given B is 0.40. Therefore, the probability of getting heads in the first toss is probability of H1 given A times probability of A plus probability of H1 given B times probability of B, and plug in the values given, and this is 0.48. Therefore, Mr. Beige's expected gain on this game without testing first is -20, what he pays for it, plus 0.48 times 250, plus 0.52 times -200, which he has to pay if he loses, and -$4. Note that the two coin tosses are independent, and therefore probability of H2 given H1 is probability of H1 and H2 divided by probability of H1. Which is the probability of H1 intersection H2 given A times probability of A plus probability of H1 intersection H2 given B times probability of B, the whole thing divided by probability of H1. That, because of independence of the tosses, that's probability of H1 given A times probability of H2 given A times probability of A plus probability of H1 given B times probability of H2 given B times probability of B over probability of H1. And we then plug in the numbers, and this is 0.6 times 0.6 times 0.4 plus 0.4 times 0.4 times 0.6, the whole thing divided by 0.48, and that's 0.5. For now, let us disregard the cost X of testing the coin and calculate the expected net payoff of the game without that additional fee. If Mr. Beige's coin test result is results in tails, his payoff for the game will be 0. Thus, the expected net payoff for the case when he tests the coin, disregarding the fee of X dollars, is -20 plus $20 times probability of complement of H1 because he gets the $20 back in this case, plus 250 times probability of H1 times probability of H2 given H1, minus $200 times probability of H1 times probability of T2 given H1. That's negative 20 plus 20 times 0.52 plus 250 times 0.48 times 0.50, and minus $200 times 0.48 times 0.50, and that's 240. This means that Mr. Beige's expected payoff changes from negative $4 to $2.40 as a result of testing the coin. In order for him to be indifferent between the two choices, the additional fee should be set at the difference of these two amounts equal to the increase in the expected payoff of the game. So it should be 240 minus negative 4, or 640, and that's answer A. Please remember this is copyrighted material. The problem was written by me and the solution is mine. Good luck in your studies and good luck on the test.